So now that we've learned about solving inequalities, now we have to talk about something called compound inequalities. Compound inequalities is when you have two inequalities in the same problem, kind of like a compound sentence. If you said something like, I am going to eat popcorn at the movies, period. I am going to eat candy at the movies, period. Instead of saying it as two separate sentences, you could combine it into a compound sentence and say, I'm going to eat popcorn and candy at the movies, and you combined it with the word and. Well, a compound inequality is when you have two inequalities, and it's either going to be combined with a word and or with the word or. And the reason it's an and or an or is because if I said something like, you have to be younger than 10 and older than 5 to play on the playground, the two inequalities that would represent that, younger than 10, so your age A would have to be younger than 10. Your age would also have to be greater than 5. And if you think about it, there are numbers that are less than 10 and greater than 5. Numbers like 6, 7, 8, 9, and all the decimals and fractions in between. So that would be considered an and inequality, and I'll show you in a second how to write that. Then there's also a different type of inequality, compound inequality, called or inequalities, and that's when you have two inequalities and it's either or. So something like you get a discount if you are younger than 3. So if you're younger than 3, that would be A is less than 3. And you also get a discount if you are older than 60. Well, if your age is older than 60, if you think about this, there are no numbers that are less than 3 and older than 60 at the same time. So we would call these or inequalities, and we would call these and again, I'm going to show you how to write them, because right now, the way I wrote them here, these are still single inequalities. We're going to have to combine them to make them what we call compound inequalities. So we'll talk about and inequalities first. All right, so you could see I have two inequalities here. X is greater than or equal to 2, and I also have X is less than 5. So if you look at this number line, you could see that if I were to go to 2 on the number line, I would say X is greater than 2, so a closed circle, and I shade in this way. Then if I graph the other one, X is less than 5, well, an open circle and less than 5 would be this way. But they have to be both of these at the same time. So if you look at the bottom here, you'll see that the graph is showing you all the numbers that are greater than 2, so going this way, and also less than 5 going that way, and the only numbers that meet those requirements are all these numbers in the middle. So we would only shade in the middle of the graph, and we call those an and inequality. And when you have an and inequality where you're shading in the middle, we call that an intersection, because if you think about it, the two sections are overlapping or intersecting. So you could see that they're writing it as one inequality. When it's an and inequality, you're going to put a variable in the middle, and then you're going to write the smaller number on the left, the greater number on the right. And if you think about what this is saying, we said X was less than 5. Well, this part right here is saying X is less than 5, right? This also is saying that X has to be greater than or equal to 2. So if you think about it, since X is in the middle here, if you read it going this way, you could see this is also saying X is greater than or equal to 2. So we just combine those two inequalities into one, and this is it right here. So we would read this as 2 is less than or equal to X, which is less than 5. And that's what we call an and inequality. It's two inequalities in one. Or inequalities, instead of an intersection, it creates something called a union. So if you look at this one, you could see it says y is less than or equal to negative 2. Y is greater than 1. Those are the two inequalities here. These are the two requirements. So if you were to graph y is less than or equal to 2, it's a closed circle at 2. And then less than is going to be this way, right? Now, the next one, y is greater than 1. So an open circle at 1, greater than 1 is going to be to the right. And you could see if you graph them both at the same time, it's going to look like this. You could see that those two sections do not overlap or intersect like they did in the last one. So this is an OR inequality. It's either the numbers less than -2 or the numbers greater than 1, but you can't have both at the same time. And that's what an OR inequality will give you. When you have an OR inequality, you literally write the word OR in between. So you write the two inequalities and you just put the word OR in the middle. Versus when you have an AND inequality, it's unfortunately not as simple. You can't write the word AND. You have to write it like this, where you put X in the middle and you write your smaller number on the left, bigger number on the right, and your inequality symbols. Now, that's just reading and graphing them. But just like we've been solving, you're going to have to solve them in a minute as well. But before we do that, let's make sure we know how to write inequalities that are compound inequalities. So the first one says a number X, so that's our variable X, is greater than -8. So X is greater than -8 and less than or equal to 4. So X is also less than or equal to 4. Those are my two inequalities. So if you think about this, first of all, hopefully you notice it says the word AND. But if you didn't notice that, or if sometimes it might not even say that, you could graph this and figure out what's going on. If I have the smaller number is -8, the bigger number is 4, it says X is greater than -8. So I open circle, and greater than is going to be all this stuff this way. Then the next one is saying X is less than or equal to 4. So a closed circle at 4, and less than is going to be to the left. And you could see that it's going to be an AND because these two sections are going to overlap. So instead of writing or coloring in all to the left and all to the right, we're just going to color in the middle because that's the only section that meets both of those requirements. So I will shade in the middle of the graph. So an open circle, closed circle here, and like I said, shading in the middle because it's an AND. Now, the way we would write this, because right now, if I write it just like this is two separate inequalities. That's not a compound inequality. A compound inequality, we have to write it as 1. So when it's an AND, we put the variable in the middle, the smaller number on the left, the greater number on the right. You could see the alligator mouth is eating the 4, so it has to eat the 4. The alligator mouth here between the X and the -8 is eating the X, so it eats the X. So this is how you would write that inequality. That means all the numbers between -8 and +4, including 4, but not including -8 because it has an open circle. This one, hopefully you see the word OR, but again, if you didn't, let's think about what this is saying. A number Y, so my variable is Y, is at most 0. If something is at most 0, that means that 0 is the biggest it can be. So it could be less than or equal to 0. It also says, or at least 2. So Y is at least 2. If Y is at least 2, that means 2 is the smallest it could be, which means it's going to be bigger or equal to 2. So those are my two inequalities. So if I were to go to graph this, again, I always put the smaller number on the left and the bigger number on the right. Both of them this time are closed circles. And it says Y is less than or equal to 0. Well, less than is going to be to the left of 0. Y is greater than or equal to 2. Greater than is going to be to the right of 2. And you could see this is not an intersection like last time. This is not an AND. This is an OR. You can't have a number that's less than 0 and greater than 2 at the same time. It's not possible. So thankfully, when it's an OR, we don't even have to write it in a fancy way. We just put the word OR in the middle. And that would be my inequality. And then below that is the correct graph. All right, now we have to talk about solving. So to solve an inequality, you'll notice, or a compound inequality, I should say, you should notice that there's two inequality symbols. Anytime you see two inequality symbols in the same problem, you know it's a compound inequality. Now, hopefully you'll also notice that this does not say the word OR. If it doesn't say the word OR, then it's an AND. It's as simple as that. All you have to determine is if it says the word OR. If it says OR, it's an OR. If it does not say OR, it's an AND. And you can see that in this one, X is not by itself. There's two inequality symbols. It's almost like two walls. So you could see that usually when we're solving equations or inequalities, there's one symbol and we draw the line and that makes it two separate rooms. But here, there's two symbols, so that actually makes it three rooms. You have a room on the left, a room on the right, and a room in the middle. So our goal is still always to get the variable by itself. Well, if you look in the middle room, you can see X is not by itself. It has a -2. So I'm going to get rid of -2 the same way as always by adding 2. However, I usually say whatever you do to one side, you have to do to the other side. But there's a middle, a left, and a right. So you'll notice over here I put my little note, whatever you do to the middle, you must do to the right and the left. So since I added 2 in the middle, I have to add 2 to the right and add 2 to the left. So let's see what I have left. All right, well, -4 plus 2 is going to give me -2. This symbol still says less than. X, and then the -2 went away there, and then the other symbol still says less than, and then 3 plus 2 is 5. So I have -2 is less than X, which is less than 5. So if I were to go to graph that, I'd put the -2 on the left, the +5 on the right. It's going to be open circles, and it's an and, which means it's going to be shaded in the middle. If you think about this, X is less than 5 means stuff this way. And then if you read it the opposite direction, X is greater than -2, which is going to be that way. So what that means is you're shading in the middle. And there is your inequality and your graph. Here you'll notice that there is two steps that you have to do to get X by itself. So the first thing I would do is subtract 1 on both sides. I get rid of addition before multiplication. So I subtract 1 from everywhere. -3 minus 1 is -4. Is less than, it still says -2x, the ones went away, is less than or equal to 9 minus 1, which is 8. Now I'm going to divide by -2 on both sides, and be careful because if you paid attention, you might notice that we just divided by a negative. When you divide by a negative, that symbol flips. So both of those symbols flip. So this less than symbol is going to turn into a greater than symbol. -4 divided by -2 is 2. This less than or equal to is going to turn into a greater than or equal to, and 8 divided by -2 is -4. You could see this looks different than the other ones. The symbols are pointing the different directions, and you'll also notice that the smaller number is on the right. The -4 is at the end versus in the beginning. So I'm going to rewrite this. I'm going to put the -4 in the beginning. I'm going to put the 2 behind it. The X in the middle. Here you can see that the alligator mouth is eating the 2, so I'll make sure it eats the 2. And then between the X and the -4, you could see it's eating the X, so I'll make sure it's eating the X. So I'll put a -4, a +2, open circle, closed circle. It's an and, it's all the numbers in between. This one is an or. So, in an or inequality, when you're solving, y is not by itself, you have to solve it, you're just going to treat it as two completely separate inequalities. So I'm going to look at this inequality first. The 3y minus 5 is less than -8, okay? I'm just solving for y, just like I normally would. So I'm going to get rid of the -5 by adding 5 on both sides, and I'm left with 3y is less than -3. Divide by 3 on both sides. Don't flip the symbol. You could see we divided by a +3. It doesn't matter that this 3 is negative. What we divided by was +3. So when I divide by +3, I get y is less than -1. Now, I have to move over and solve the next one. So the first thing I'll do here is add 1 on both sides. I'm left with 2y is greater than 6. Divide by 2 on both sides, and I get y is greater than 3, and all you do is you put the word or in the middle here. So you put these two together by writing the word or. So I have y is less than negative 1, or y is greater than 3. And of course, we have to graph that. So I'll put the negative 1, the positive 3, open circles for both. This time it's not the middle. It's y is less than negative 1, or y is greater than 3. So you could see it's shaded in on the outsides. This is some practice that I had everyone do on their own. So the last thing I'm going to do is move on to the last slide because I want to, or the second to last slide, because I want to make sure we understand how to write a compound inequality from a graph. So if we look at this first one that I have with the blue post-it behind it, right away you want to ask yourself, what kind of inequality is this? Well, you could tell by the way it's shaded in that this is an or, because it's pointing outwards like this. So it's definitely an or. So if it's an or, we're going to write the word or in the middle, and we're going to just write it as two separate inequalities. So I'm going to look at this part here. Well, I'm going to say that this is telling me that my variable is less than or equal to negative 4. So any variable you want, I'll use x. X is less than or equal to, because this circle is colored in right here, so x is less than or equal to negative 4. Or now I'm going to look at this inequality. Well, it's telling me that it's all the numbers greater than 5 and also including 5, because that 5 is colored in. So we would say x is greater than or equal to positive 5, and that would be my inequality. The next one, you look at it and you'll notice it's an intersection. It's all the stuff in the middle, which makes it a and. We don't write the word and in the middle. When it's an and, we're going to put a variable in the middle, so I'll use x. We're going to use the smaller number, which in this case is negative 5, and then write the bigger number 4 on the right. And then you could see it's all the numbers smaller than 4, so x is less than or equal to, because it has a closed circle. And then it's the numbers greater than 5. However, be careful. I'm not going to write a greater than symbol here. I have to think about what x is, and since x is behind the negative 5, if x is greater, it has to eat the x. And I don't put an or equal to sign because it's an open circle. So that would be my inequality there. And that is the lesson. I would suggest you go and practice by going back to some of these here and practicing solving and graphing. But that is pretty much it.